Hi, everybody. We are going to look at probability today. I'm not going too in depth with this. This is just kind of early on for my seventh graders in the advanced class. For Indiana, you can see the seventh grade standards that are listed there, but we're just going to focus on like the basics of finding probability in this video. So, first of all, I want to talk about how to describe the likelihood of an event. Think of it like a number line. The beginning of your number line is a 0. There's a 0% chance of that event happening. It's completely impossible. It just can't happen. If you have red, blue, and yellow markers, and I ask you the probability of picking out a purple to color with, there's no purple in there. It can't happen. The other end of that spectrum, the other side or the other end of your number line is a 1. So it's like if there's 6 socks and I don't know, some are black, some are white, but I don't specify a color. I just say reach in your drawer and pull out a sock. Well, 6 out of 6 of those are socks, right? 6 out of 6 reduces to 1. There's 100% chance that's going to happen. It's certain. There's nothing else that can happen but whatever was described. Exactly in the middle is when there's a 1/2 chance. You're flipping a coin. The chances of getting heads is 1 out of 2. There's a 50% chance that that's going to happen. That's described as either equally likely or sometimes you'll hear as likely as not, but it means it could just as easily fall one way as it could the other. If it falls between 0% and 50%, it's not impossible, but it's unlikely. And if it's between 50% and 100%, it's not certain, but it's likely. So the first thing in 7th grade that we're usually asked to do is to describe the likelihood of events. So over here on the left, we have marbles that are very well drawn by yours truly. Thank you very much. So we've got 2 red. I see 4 blue and 3 green. Altogether, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 marbles. So if I want to find the probability of getting a blue, if I have 10 marbles, figure out what half of that would be. So half would be 5, right? 5 would be 50%. So if I'm looking at a blue, there's 4. 4's less than half. There's blue there, so it's not impossible, but it's less than that halfway marker. So for the probability of blue, I would describe that as unlikely. If I can get this to cooperate and write for me. The probability of green, again, there's green there, so it's not impossible. I see 3 of them. 3 is less than that halfway point of 5. So I would also call green unlikely. My stylus is not cooperating. I feel like that happens every time I record videos anymore. It's driving me nuts. The probability of a blue or an orange. Okay, well, I see 4 blue. I see 1 orange. That's 5. That's exactly half. So you can describe that as equally likely, or you can say as likely as not. The next one says probability of a red or a blue. I see 2 red and 4 blue. That's 6. That's more than the halfway mark. So that I would describe as likely. If I had asked you the probability of getting, I don't know, a black, none of them are black. So that would be impossible. There's a 0% chance. If I had said the probability of getting a red, blue, green, or orange, that would be certain because those are the only possible choices there. So when you actually want to write the probability, you always start it out as a fraction. The bottom, the denominator, is how many outcomes there are total. So looking at the same set of marbles here, whatever, there are 10 of them. So the bottom of my fraction is going to be 10. The top number is however many of the thing it's asking you for. So if it's asking you for green, it's the number of green. If it's asking you for red, it's the number of red. This is called the theoretical probability. It's what should happen. So in theory, because there's one orange. 1 out of every 10 times I pull out a marble should be orange. But we know it's not necessarily true. It's possible that could happen more than just 1 out of every 10 times. It's possible I might not pick out that one little lone orange at all in 10 times. But this is just kind of used to make predictions based on what should happen. So in theory, the probability of a blue, on the bottom, I'm going to put 10 because there's 10 marbles. 4 of them are blue. So 4 is going to be my numerator, my top number. And then I want to reduce. Divide those by 2. 4/10 reduces to 2/5. If you're asked to write that as a decimal, take top divided by bottom. Top divided by bottom is going to give you 0.4. If you're asked to write it as a percent, once you have your decimal, you're going to take that decimal and scoot 2 places to the right. That's going to become 40%. If they ask me about the likelihood, we know that's less than half. That's unlikely. It's less than 50%. Probability of green, we talked about how this one is also unlikely because it's less than 50%. Out of those 10 marbles, 3 of them are green. That doesn't reduce, so there's my fraction. 3/10 can be written as 0.3. And then scoot to the right. That's the same thing as 30%. There's a 30% chance that you're going to reach in and get a green. A blue or an orange. So I'm going to add all those together. So out of the 10, blue and orange put together, there are 5 of them. 5 out of 10 reduces to 1/2. 1/2 is the same as 0.5. And we already know that that's a 50% chance. We talked about that on the slide before. Red or blue. Okay, so that's 2 plus 4. There's 6 of them. 6 over 10, divide those by 2, you get 3 over 5. 3 divided by 5 is 0.6 if I'm asked for a decimal. Scoot to the right if I'm asked for a percent. That would be 60%. If it asks you anything about a complementary event, the complement, when you're talking about probability, is everything else. So for blue, that was 4 out of 10. So that means the complement would be 6 out of 10. And then you can reduce it and do the decimal and percent if you need to from there. But complement or complementary events, complementary of events, what, Luger? Complementary events or complementary of an event. Ah, my goodness, it wouldn't be a Luger video if I didn't do or say something stupid. The probability of a green. Okay, so we already talked about how there's 3 of those, 3 out of 10. So the complement is the rest of them. If 3 were green, that means 7 were not. Probability of blue or orange, there were 5 of them. So then the complement is everything else, the other 5 out of 10. And again, you can reduce, you can find decimals, you can change it to a percent. I just need you to know that it's everything else that makes up the total. Now, if you had been given the percent to begin with instead of the fraction, so like if I had said, if you didn't even have a picture, and all I said was the probability of getting a red or a blue is 60%, and that's all you knew. The entire thing represents 100%. So 100 minus 60% is 40%. So no matter how it's given to you, just remember that everything else is the complement. If on the green, if I hadn't given you 3 out of 10 and you didn't have a picture and all I said the probability was 0.3, the full thing, 100%, that's the same thing as one whole. 1 minus 0.3 is 0.7. So even if you don't have the picture, as long as you have the information for what the event is, the complement or the complementary event to that is just the whole thing minus what you've used up. Okay? All right. So Last thing we need to talk about. Everything we've said so far has been referencing what's called theoretical probability. And I mentioned that on the first problem that we did. Theoretical is what should happen in theory. In theory, you toss a coin, 1 out of every 2 times should be heads. In theory, you roll a die, and 1 out of every 6 rolls should be a 3. But in reality, it doesn't always happen that way. In theory, half of the time you roll, you should be getting an even number. So in theory, if you roll 50 times, 25 of those should be even. But that's not always exactly the case. If you actually go ahead and do the thing that it's talking about, you actually toss the coin however many times, you actually roll the die, you actually draw the marble out of the bag, and you put tally marks and you track how many times the things are happening, that's called the experimental probability. It's what actually happens when you do it and find the probability. So let's pretend like I rolled a die 50 times. And out of those 50 times, I rolled a 1 7 times. I rolled a 2 6 times. 3 I got 10 times. 4 I got 11 times. 5 I got 10 times. And 6 I got 6 times. So in reality, out of those 50, let's see the evens. 6 and 11 is 17, plus 6 is 23. In reality, 23 out of 50 were my evens. That would be 0.46 if you take top divided by bottom, or 46%. In theory, it should have been 50%. It should have been 25 out of 50. But in reality, it was a little bit less than that. So sometimes you'll be asked to find the experimental, find the theoretical, and then compare. Show which one's less than the other or whatever. But just remember, theoretical is what should happen. Experimental is what actually happens. Okay? So that's just a basic little rundown of probability. Thanks for watching. Feel free to subscribe if you need help with any other middle school math videos. But until next time, thanks again. Bye-bye.